Yeah, I want. There's two things I want to get back to. It was the development. I actually want to hear a little bit of the story of it, and I also want to talk a little bit about ground conditions, which is there's a case study link that I want to cover in that. But before we do that, um, Michael, can you just walk us through? And we'll bring up this video. Can you just walk us through what the zero trip wedge actually does, like, and how to install it, how it works, everything, sort of in detail?
The wedge I was using originally back in the mid 90s was known as a Halrow wedge. So it basically you had to go down, insert a plug. So you had to lower all your rods down the borehole, insert a plug, plug the hole, come back up with all your rods, take them all out. This could take a whole shift depending on what depth you're in. Next shift, you go down with a timber. It was a special American softwood timber so that it expands in the hole. And basically, you come back up and you go down with a steel wedge. It's a pretty basic tool. It's like a spade. And when you orientate it to wherever you want to go, what direction, you insert it into the timber. And you had some brass rivets holding your dropping bar onto the wedge, and you shear those rivets by pushing down on the timber. And that was okay. Wedge set. Then back up the hole you come again with your drill rods, and you put on your core barrel. And your core barrel is a piece of equipment that drills off the wedge into a new borehole. So you establish a new borehole at wherever you set this wedge at. So it is very labor intensive. You could be 4-5 shifts doing this. But the most frustrating thing was, I suppose, in the late 90s, I took over as foreman back in the project in Ireland. And basically, we had issues with sensitive ground conditions. When you're tripping rods up and down a borehole where the ground is very unstable, what can happen when you lower your timber plug in the borehole and come back up? You can destabilize the borehole. And when you're going back down with your steel anchor or spade, you can find a lot of cave sitting in top of your piece of wood. And next thing, your spade doesn't insert that well into the wood. It has no anchoring system to keep the wedge against the back wall. When I say the back wall, this is about 4.5 meters long, this tapered piece of steel. And
Okay.
the biggest issue in drilling, because I'm a driller, is that you go to change your bit, and when you go back down after replacing your drill bit, you go back down, next in the wedge is out across the hole, and you can't get past it. So umpteen issues used to happen with the Halrow wedge. Grand, if ground conditions are good, no problem. But if ground conditions are sensitive, absolute nightmare, can be a nightmare. So that's where the zero trip wedge came about. But there was two, let me go back a small bit further. Back in the 60s, there was two systems basically competing against each other. You had the Borehole long ear, which had a spike for pulling a tube. Now, drillers will know this. The general public will say, what the hell am I talking about? But you had a spike, a spear, and that was the system that, took over. But there was another system called a quad latch, a Christian quad latch system. And this Christian quad latch system was the key to me to developing the zero trip wedge, because it allowed me to put an orientation receiver for a camera inside a quad latch. And I could then find where my position was, my orientation in the borehole. Now, when I designed this originally and brought it to the market, people couldn't understand how the heck did I know where the wedge was facing. All right. Because when you go set traditional wedges, everybody was going down the borehole with non-magnetic chrome pipes. So you'd normally take 6 meters of a non-magnetic rod down behind your wedge so that you could drop in your camera and see where the borehole is facing, what angle, where you want to go. So everybody was doing that. That was the industry norm. But I said, you're going down, taking a survey of information you know already. you've already completed the borehole, you've taken a survey from the bottom to the top, and you've decided where you want to kick off to the way where you want to put the wedge. So you know the magnetic azimuth, or you know the azimuth, you know the incline, you know all that information. So from directional drilling, in my experience, you have two options on a camera. You have magnetic north, and you have what's known as GR angle. GR angle is grid rotation. So its starting point of measurement is the high side of the hole, right? So you still with me?
Yeah.
So the high side of the hole is always equal to the azimuth of the hole, right? So magnetic north starts from magnetic north. Now the two will end up in the same area readings, but they start from two different points. One starts from magnetic north, one starts from the high side of the hole, which is equal to the azimuth of the hole. So I was able to determine where the wedge was facing with steel rods in the hole, and that was the big difference. I could determine where the wedge was without having non-magnetic rods in the hole.